Okay, so I have to make my graduation project for my college, and I was thinking about recording the whole process so that it actually serves some other purpose other than getting a grade. And I will be making a web application in Haskell that will use some machine learning and some optimization algorithms, nothing too advanced, some simple stuff. And I will generally try to explore good software development practices in functional programming language, and also some best practices for implementing different algorithms. And this series won't be really about just programming, because programming is just one part of software development. This will be more about software development as a whole. So in this first episode I will start with creating a Git repository and showing you some basic Git commands, because I've noticed that a lot of my colleagues don't really know any of these basics. So I'll go through designing a database, creating a database, creating a good project structure in Haskell, and some other things as well. But for now, let's just go and see how to do some basic Git stuff. So I'll first create a new repository on GitHub, and just in case you don't know, GitHub is not Git. GitHub is just one of many available services where you can host your code and manage it with Git, which is actually a software for managing code and versions of your code. So here I'm creating a new repository in my namespace, and I will call this one Cookster because I'm making a cooking application. And I will just write the description of my project. There we go. I will leave this as public repository so that everyone can see the code. And if you're choosing a private repository, then you have to pay. If you need a private repository that's free, you can go to Bitbucket instead of GitHub. I think they actually have unlimited free private repositories. And I will also tell GitHub to initialize my repository with a README file. And since I will be making this project in Haskell, I will also add a Haskell git ignore file, like so. And the license, well, I'm not sure if I need one, but let's just pick a GNU for these purposes. And if you're developing a commercial, or maybe it's a somewhat more serious project, you should try to pick your license wisely, because if you're using some piece of code, some library that has different licensing, that might clash with your general project license, then you might have some problems down the line. Anyway, let's just go and create this repository. And there we go, we have a repository, we have a git ignore file, a license file, and a readme, which basically is introductory text when someone opens our repository on GitHub. Okay, so now we have our repository on the internet, but we need to get it on our computer so that we can actually do something with it. So we'll clone this repository, and I'll just copy this URL. And I'm assuming that you already have Git installed on your machine, so I will not be covering this step. You have many tutorials about it. So I'm just going to shift right click and open a command window here, and to clone the repository, just type in git clone and paste the URL, and that should be it. Okay, so now that I have my repository cloned, we have all these files in here. And one recommendation, if you're on Windows, or any other operating system, try to enable your hidden items so that you can see this invisible Git directory. This is where Git will store all your, save files, let's call them like that, for your code, all the save points and some other Git related stuff. And this is also how Git knows that this is actually a Git project in this folder. So existence of this folder is crucial, and you can see that we already have some files in here. Okay, so let's get back to the console, and I will just switch to this folder, and let's type in git status just to see if we have something to commit. And since this is a new repository, there's nothing here. So let's initialize this folder with the new Haskell stack project. So in the next video I will go more in detail about stack tool for Haskell, but for now let's just type in stack new name of the project is Cookster, and actually let me just see what are the commands. I think we want to actually no. Yeah, so we want to pass the bear flag, because if I type in stack new Cookster, it will create a subdirectory named Cookster within the directory Cookster, and I will basically have a project within a project, which is not what I want. And I think that stack actually creates its own license file, so I will just rename this temporarily so it doesn't get overridden. And we need to pass the flag bear, and okay, that should be it. So now we have new files in here. This is just a project structure, and yeah, there's a license file. I will just delete this and rename this back to license. Yes, please. So if I try to run git status now, I should see my new files in here, and they're not yet added to the tracking. So first of all, let's create a new git branch, or actually maybe not. Let's just roll with it for a moment. So currently, when I executed git status, Git is telling us that he has these new files and folders over here that he is not tracking. And you don't need to do anything about them in case you don't want them to be tracked. But we want them to be tracked, so let's go and add them. Let's use a git add command. And it's when you're adding a new file to already existing project, it's a good practice to be very specific about what you're adding. So we would usually type in specifically the name of the file, in this case Cookster, and then the name of the setup and the folder that we wish to add. But since we're currently just initializing this project, we can just type in dot, which will add everything. And here we are just getting some warnings about line endings. This is endless war between Windows and Unix style line endings. So I will just ignore this, it's not important. And let's try to run git status now. So now Git is telling us that we have these new files, new changes that have to be committed, and commit is essentially a save file of our project, a point in time where our project looked a certain way. So let's go and and commit these changes. So we can type in git commit and just hit enter, and now Git will open a Vim editor or something else that you have specified. And in here we just need to write, a message telling us about what our commit was actually about. So since we are in Vim, we need to go into insert mode. So just press I on your keyboard and notice in here at the bottom insert is shown. So this means that we can actually type normally in here, and we'll just type that this was like what I don't know, stack initialization or something like that. And when you're done writing your message, just press escape key, and as you can see, we're out of the insert mode and we are inside of command mode. So now just press colon and W and Q. You can see again down in here, and this essentially tells Vim to write and quit the file. So this will save the file and quit, and this will give Git a sign that he should write all of these changes and create a new save point of our project. So if I try to run git status, we can see that now everything is clean and there is nothing to commit. So if we go over to the Git and if we refresh, we will not see any of these files, because this commit is only local to our machine. So now we need to, as you can see, it tells us here, now we need to actually push all of these new changes to our master repository, let's call it this way. A repository where everyone in the team will synchronize. And for that we can type in git push origin. So origin is essentially origin of our repository, because we can have a local origin, or we can have actually no, I'm talking shit. This is like a branch in a way. We currently want to push to the master branch on the origin, and this is our origin. So let's just type in push origin master, and excuse me, my voice is going off. So if you're doing this for the first time, you might be asked for your GitHub password, and so you should just enter your credentials, or you can set up SSH keys, but this is not something I will cover at this point. Maybe later when I'll show you how to run the code on the server, we'll need to do some SSH and connect to the server and actually run the application on the web. So let's see if I try and refresh this now. You can see that we have all of our files online, so that's nice. And there is a quicker way of committing things. So let me just quickly show you that. Let's go and make some change to the README file, and I'll just add enter, and this is a test, like so. So again, git status, just so that you can see that Git now warns us that that we have modified the README file, and we can just type in git commit a, and this is to just commit all the modified files without actually adding new files that we might not actually want to track. And then we can also pass the M flag, which is the message flag, and here we can type in the message instead of going into the Vim, and I will type in this is a demonstration, like so. Okay, so we have successfully committed our changes without actually going into Vim, and now we need to again push them to to our master, so actually to the origin, like so. Oops, I guess I have paused things, so let me just go back to the code. Yeah, so now we have our new demonstration file over here, changes that I've made to the README, and all the files that were within a certain commit will have a message of that commit by their side. So if you click on this message, you can see what was added. You can see that these are 2 lines, and you can also see all the files that were added and or modified within that commit. So if we go over to the stack initialization, and let's just wait a little bit, the internet is slow for some reason. Okay, so in here you can see that we have our Cabal file. These are all the new added changes. So these are basically all the files that Stack has created for us and that we have added to the tracking for our Git. Yeah, anyway, so one last thing we need to do. Now, you usually don't want to make all the changes on the master branch. So you generally want to use a master branch as some kind of final destination for the codes, for versioning of your software. So whenever you push something to the master, it's a good practice for it to be fully functional and have all the different features that you intended to implement, so that you can actually run every and so that you basically have a fully functioning piece of software with every master commit. So a good practice is to create another branch, development branch, or whatever you want to call it, and do all the development and changes and messy things there, and then when you're done with a certain part of your development process, you just push to the master, so that in that way you have more cleaner workflow. So let's go and create a new branch. So to see all the branches that we currently have, you can just type in git branch command. Okay, so we currently have only master, so we can just type in git branch and let's call it dev. So we have created a new branch. Let's see if it's here. It's here. And then, as you can see, master is our current branch, so we need to switch to the dev branch, and we can do this by typing in git checkout dev. So now when we commit something, it will be committed to the dev branch, and let's just check one more time. We are now on the dev. Okay, so let's test this out. I'll make another test. Like so, and get status, yeah. Like so, git push. And we are pushing to the dev branch on the origin, so be careful about that. Okay. And if I refresh this now, you won't see anything, but you can see that we have a new push to the dev branch, and if we go and switch over to the dev branch, we should see over here a new test for the dev branch. Right. Okay, so I think this should be enough for Git basics, and I will see you in the next video.